Hi everyone, in today's class we'll be treating heat capacity, specific heat capacity, latent heat for different change of state. Now we'll start with heat capacity. Now heat capacity is the energy required to raise the temperature of a body by 1 Kelvin. Let me go over that again. Heat capacity is the amount of heat required to raise the temperature of a mass of a body mass by 1 Kelvin. Now that what that means is that what is the amount of energy you need to put into a body to raise its temperature by 1 Kelvin. That's basically what that means. Now, whereas specific heat capacity is the energy required to raise 1 kilogram or 1 gram, because sometimes it might be interchange. Is the energy required to raise the temperature of 1 gram or 1 kilogram of an object, of a body, of a substance by 1 Kelvin. You can see that is specific. 1 kilogram, unlike that of heat capacity that is just the entire mass of the body. It's not really precise. So that's specific heat capacity and heat capacity. Now there are ways in which you use heat capacity. There is a way easy way to calculate heat capacity, specific heat capacity. And let's go over this now. Heat energy is the total of all kinetic energy and potential energy the atoms in an object possess. We already explained this when we were talking about heat energy, heat transferred. And just to go over it again, you know that the more faster the molecules of the substance move, the higher the heat energy they have. One of the reasons why when you are boiling water, you know that what signifies that the temperature is extremely high is when the stuff starts to like bubble up. Now to calculate, for a specific heat capacity, the formula of calculating your specific heat capacity is not the calculate. If you're trying to calculate the heat energy that you actually supply to a body, what you need is the mass. You need the mass of the object, or you need the mass of the body itself, and then you need the temperature difference, like the rise in temperature. The rise in temperature. You need the rise in temperature as well, and then you now need the specific heat capacity of the body. Now instead of using specific heat capacity, you can use heat capacity, where you just need heat capacity times the temperature difference. But then if you are going to be using specific capacity, you have to include the mass. If you are going to use heat capacity alone, the mass will not be present anymore. I hope you understand that, because for specific capacity is what per kilogram, so you have to add the mass in which that you're actually supplying the heat to, and then for heat capacity alone there is no mass, so it's just this heat capacity times the temperature difference. I hope you understand that, and even from the formula you can derive the definition from it, so you shouldn't have any problem once you're able to record the formulas in your example. This is why I always tell people there are a lot of information in the formula itself, and you can still memorize a lot more formulas than actually reading the stuff word for word. So from the formula you should be able to get the definition for specific capacity and capacity. Now the way these are usually used is they will ask you a question, they'll give you the mass of an object, they give you the specific capacity, they will tell you the temperature rose from 15 degrees Celsius to 20 something degrees Celsius. Now take note that that's in degrees Celsius, yes, but when you convert Celsius to Kelvin, you see the difference is still the same. So in exam, or you might not actually have to convert to be doing conversion when you are dealing with heat capacity, specific capacity. I hope you get. But then in other place, I think you have to convert it, because some are always not. But anytime you are dealing with difference in temperature, you are given Celsius, just know that the difference in Celsius will be the same as the difference in Kelvin. So we already talk about the different temperature scale that we have. We have Kelvin, we have Rankine, you have Celsius, you have Fahrenheit. We already discussed that. So that's how for specific heat capacity and heat capacity. And now the way you will use this, I think I already went over that. The way to use it, you give mass, you give specific heat. And they always tend to use that of water. They use the heat of water, and then you now give you the temperature difference, and then you have to calculate the amount of heat energy supplied. Now it might be different in the fact that they might give you the heat energy supplied Because you might say, okay, the heat energy was transferred from a body that was hot, so that the temperature of that body reduced to so, and then um, the temperature of the other one increased by this amount. So you have to equate the heat energy lost by the other body to, then you equate it to the heat energy gained by the other body. I hope you get. So that basically the specific capacity and heat capacity is actually quite very straightforward. So these are some specific capacity for some substances: water, ice, aluminium, copper, gold. Now, once you solve a lot of questions enough, sometimes the answer for you to do when you are doing physics now is solve a lot of questions. When you've done a lot of solving, some of these values will come naturally to you. That of water and that of ice, it will come like very very naturally to you because you'll have seen it over and over and over again. So this is an example of the stuff I'm talking about, of how you might be asked the question. You can pause the video and try and attempt it yourself. Then you check the workings and the answers. Okay, I think this is like very very well self-explanatory. Okay, so your exams, you always be given the specific capacity of a substance, so you do not need to memorize any values. They will always give you like most values they will always give you, but then some of these values you might not even really need to even like memorize. Once you solve a lot of questions, it naturally sticks. And then make sure that the theta T is the change in temperature, therefore it can be in Kelvin, as I said before. Now let's go to specific latent heat. Now specific latent heat is the energy required to change the state of a substance. So that means that specific latent heat can only occur when there is change of state. So some of the change of state that we have is what? Vaporization, evaporation, sublimation, freezing, and condensation. But then the one you most likely be asked about, the one that is more specific to this, is you have melting, you have vaporization. Those are the ones that you'll be asked. And take note that for melting is the value for melting is the same for the value for solidification. Like when the stuff is being solidified, it's just like in the opposite direction to it. Like in the case of melting, you are supplying it. In the case of solidification, you are removing it from it. But then the value is still the same. So is the amount of energy required to change the state of a substance. So specific latent heat is now the energy required to change the state of 1 kilogram of a substance or 1 gram of a substance, depending on what you have given. So also when you're trying to deal with questions like this, you have to check your the values you are given. The specific heat capacity that you are given or specific latent heat sometimes might be in gram, and sometimes it might be in kilogram. So you have to actually watch out for those. Okay, and take note that there is no change in temperature because we are going to change the state. All the energy that you are supplying is being more like directed to breaking bonds within the substance. So there's really no change in temperature. The temperature is the same, but then the heat energy is going directly to breaking bonds within the molecules. So the specific latent heat of fusion is that of melting. Specific latent heat of vaporization is that of boiling. As I said before, it can be in the reverse. So if you are solidifying a liquid now, it is still the same value of specific latent heat of fusion that you are going to use. Okay, so now specific latent heat of fusion is the energy required to convert 1 kilogram of a solid to liquid with no change in temperature. As I said before, this is used in melting a solid or in freezing a liquid. So it can go in either direction, just like the direction of the energy you are supplying will not be different. If you are melting it, you are supplying its energy to it. If you are solidifying it, you are removing that amount of energy from it. But for vaporization is the energy required to convert 1 kilogram of a liquid to gas with no change in temperature. It can also be the reverse case as well too. So this is the formula to calculate. So if you have to calculate the heat energy required to change the state of a substance from this to this, what you use is the change in the mass. You need the mass, and then you need the specific latent heat, and then you are good to you get the answer. But the way they most likely give you is you have a body supplying the heat, and then they will ask you have to calculate the heat lost or the heat energy lost by that body, and then it will be equal to the heat energy supplied to the other body to cause the change of state. Okay, so I think that should be all for specific latent heat capacity, um, specific heat capacity. So see you guys in the next class.